Hello, everyone, and welcome to our Introduction to Statistics lecture. This is the first lecture in the course. Today, we'll explore the definition of statistics, classifications, applications, and limitations of the subject. Whether you're new to statistics or brushing up on the basics, this session will give you a solid foundation. So, let's get started. Definition of statistics to start off. Let's clarify what we mean by statistics. In simple terms, statistics is the science of collecting, organizing, analyzing, and interpreting data. It's a field that helps us make sense of the data we encounter every day and supports evidence-based decision-making in numerous fields. In a more formal sense, statistics can be defined as a branch of mathematics that involves methods for gathering data, summarizing and interpreting information, and making inferences from data. The goal is to transform raw data into meaningful insights, patterns, and conclusions. Think of statistics as the science of data, where we aim to understand and use data in ways that reveal the underlying truths of a phenomenon. Now, it's worth noting that statistics isn't just about numbers. It's about drawing insights and making sense of those numbers in a way that can inform decisions, solve problems, and even predict future outcomes. Let's start with the journey of data transformation. As you can see, the process involves 4 key steps: data collection, data organization, data analysis, and data interpretation. Data collection is our first step. This is where we gather information from various sources. For example, data can be collected through surveys, experiments, observations, or digital data logs. This step ensures we have the raw material data to work with. Next, we move to data organization. At this stage, we systematically arrange and structure our data, often in tables, databases, or spreadsheets. This helps prepare the data for easier analysis by giving it a clear, logical order. The third step is data analysis. Here, we examine the data to identify patterns, trends, or relationships. This could involve calculations, statistical tests, or visualizations. The goal is to start making sense of the numbers and begin uncovering insights. Finally, we reach data interpretation. This is where we make sense of the analyzed data to derive meaningful insights. Interpretation involves translating statistical findings into understandable results that inform decision-making or future actions. Together, these steps turn raw data into insights that can drive decisions, policy changes, or further investigations. 2. Classification of statistics. Moving on, let's discuss the 2 primary classifications of statistics: descriptive and inferential statistics. These are 2 main branches within the field, each with its own unique role and methods. Descriptive statistics. Descriptive statistics is the branch focused on summarizing and organizing data. Here, we use tools to describe the main features of a data set. This includes calculating measures of central tendency like the mean, median, and mode, which tell us about the center or average values in the data. We also calculate measures of dispersion like the range, variance, and standard deviation, which give us an idea of how spread out the data is around the center. Additionally, descriptive statistics often include data visualization techniques, such as charts and graphs, which provide a visual summary of data, making it easier to interpret and communicate findings. Descriptive statistics is primarily observational. It provides a snapshot of the data but does not make predictions or draw conclusions beyond the data at hand. Descriptive statistics allow us to answer questions like, what is the average score on an exam? Or, what is the distribution of ages in a population? Essentially, descriptive statistics describes and summarizes the main features of a dataset. On the other hand, inferential statistics allows us to make predictions or inferences about a larger population based on a sample. This branch of statistics relies on probabilistic techniques to make educated guesses about population characteristics. Key tools in inferential statistics include hypothesis testing, a process that allows us to test assumptions about a population, such as whether a new drug is more effective than an old one. Confidence intervals. These give us a range of values that we expect a population parameter to fall within, giving us a measure of certainty in our estimates. Regression analysis. a technique used to understand relationships between variables and make predictions based on those relationships. While descriptive statistics summarize data, inferential statistics help us generalize from a sample to a population, offering insights and making predictions beyond the observed data. Applications of statistics. Now, let's talk about some of the powerful applications of statistics. Statistics is not just confined to the classroom. It's used in a vast range of fields and industries to make critical decisions. In business, statistics is essential for market research, quality control, and financial analysis. Companies use statistical analysis to understand consumer behavior, track sales trends, manage inventory, and optimize profits. Economists use statistics to analyze economic data, forecast trends, and make policy recommendations. In the field of health and medicine, statistics plays a vital role in clinical trials, epidemiology, and public health research. Medical professionals use statistics to evaluate the effectiveness of new treatments, understand the spread of diseases, and make data-driven decisions to improve healthcare outcomes. In social sciences, sociologists, psychologists, and political scientists all rely on statistics to study human behavior, understand societal trends, and analyze public opinion. For example, survey statistics are commonly used in social sciences to gauge public attitudes or preferences. In government and policymaking, governments use statistics to allocate resources, develop policies, and assess the impact of interventions. For instance, census data provides valuable information on population demographics, which helps in planning for schools, hospitals, and infrastructure. In education, statistics help in assessing student performance, evaluating educational interventions, and improving teaching methodologies. By analyzing test scores and other academic metrics, educators and policymakers can make data-driven decisions that enhance the learning experience. As you can see, statistics is a universal tool that aids in evidence-based decision-making across countless disciplines. It's the backbone of informed, data-driven actions. Limitations of statistics. Now that we've discussed the uses of statistics, it's important to recognize its limitations. While statistics is a powerful tool, it has certain limitations that we should always keep in mind. 1. Dependence on quality of data. The accuracy of statistical analysis is only as good as the data it's based on. If the data collected is biased, incomplete, or inaccurate, the results will be flawed. Garbage in, garbage out is a common phrase in statistics, emphasizing that poor data quality leads to unreliable conclusions. 2. Potential for misinterpretation. Statistics can be complex, and without a proper understanding of statistical methods, there's a risk of misinterpretation. For instance, correlation does not imply causation. Just because two variables are correlated doesn't mean one causes the other, yet this is a common mistake. 3. Limited scope for qualitative insights. Statistics primarily focuses on quantitative data, which may not capture the full complexity of certain phenomena. For example, human emotions, cultural factors, or individual motivations might be challenging to quantify accurately, making it hard to fully understand complex social behaviors with statistics alone. 4. Subject to sampling error. In inferential statistics, we rely on samples to make generalizations about a larger population. However, if the sample is not representative of the population, the results can be misleading. Even with a well-selected sample, there's always a margin of error. 5. Can be manipulated or misused. Statistics can be manipulated to support a particular viewpoint, leading to biased conclusions. By choosing specific data points, adjusting scales, or omitting relevant information, one can present a misleading picture. It's important to approach statistical results critically and be aware of potential biases. So, while statistics is a valuable tool, it's not perfect. It requires careful application, and we must be aware of these limitations when interpreting results. To wrap up, let's review what we've covered in this introduction to statistics. We define statistics as the science of data, involving the collection, organization, analysis, and interpretation of information. We then explored the two primary branches of statistics: descriptive and inferential statistics. After that, we looked at how statistics is applied in various fields, from business to healthcare, to help in making informed decisions. And finally, we discussed the limitations of statistics, reminding us that while statistics is powerful, it must be used carefully and critically. Thank you for joining this lecture on statistics. If you found this video helpful, don't forget to like, subscribe, and hit the bell icon for more insights into the fascinating world of business and economics.